My name is Intan Rashidin binti Uzair. My metric number is 11 DKA18F 2009. Today I want to present about applied Bernoulli's equation in flow analysis. Flow through pipe in series. Pipe in series defined as the pipe of different length and different diameters connected and in series to form a pipeline. This is example for pipelines in series.
This is example question for flow through pipe in series. The question is, a pipe of 300 meter diameter is 400 meter long. Find the flow rate of water that flowing through pipe connected to tank as shown on figure below. Take in consideration of type of energy losses. Take coefficient of friction F equal by 0.0052. The solution is length of pipe is equal by 400 meter, diameter 300 meter equal by 0.3 meter, flow rate is equal by 0.0052. Energy at point A equal by energy at point B. P1 divided by W plus by V1 divided by 2G plus Z1 equal by P2 divided by W plus V2 divided by 2G plus Z2 plus N3 plus friction plus AZ. Z1 minus by Z2 equal by 0.5 V square divided by 2G plus 4 FLV square divided by 2GD plus V square divided by 2G. 46 equal by 0.5 V square divided by 2 times 9.81 plus 4 times 0.0052 times 400 V square divided by 2 times 9.81 times 0.3 plus V2 divided by 2 times 9.81. Then the answer is 46 equal by 1.49 V square. The answer for V square is 30.87. Then we do a square root. So the answer for V is 5.56. The answer for flow rate is AV equal by pi times 0.32 divided by 4 times 5.56. So the answer is 0.39 meter cube per second.
Flow through pipes in parallel. Sometimes, in order to increase the discharge from one tank into another, a new pipe has to be laid along with the existing one. Such an arrangement is known as pipe in parallel as shown in figure below. This is example for pipe in parallel. Little consideration will show that as the pipes are parallel, therefore the loss of heat for all the pipes will be the same and all the pipes will discharge water independently. The total discharge through all the pipes will be the sum of the discharge in the various pipes.
This is example question for flow through pipe in parallel. Find discharge from pipe 1 and pipe 2 as shown in figure below. There is the table. Pipe 1 is 50 diameter in mm and the length of pipe 1 is 100 meter. Pipe 2, the diameter is 100 millimeter and the length for pipe 2 is 100 meter. Take in consideration all types of losses and coefficient of friction is equal by 0.008, There is the figure shown below. The solution is PA divided by W plus VA divided by 2G plus ZA equal by PB divided by W plus VB square divided by 2G plus ZB plus 0.5 V1 square divided by 2G plus 4FL1 square times V1 divided by 2GD plus V1 square divided by 2G. ZA minus ZB equal by 0.5 V square divided by 2G plus 4FLV square divided by 2GD plus V1 square divided by 2G. So the answer is 10 equal by 0.5 V divided by 2G plus 4 times 0.008 times 100 times V1 square divided by 0.05 times 2G. So the answer is 10 equal by 3.287 V1 square. V1 square equal by 3.04 meter. So the answer is V1 equal by 1.74 meter per second. Where is Q1 equal by A1 times V1 equal by pi times x times 0.05 square divided by 4 times 1.74 equal by 3.42 times 10 power of negative 3 meter cube per second. For parallel pipe, H equal by FLI square divided by 3D power of 5 equal by FL2 times Q2 per cube divided by 3D power of 5. So the answer is Q1 square divided by 3D1 power of 5 equal by Q2 square divided by 3D power of 5. Q2 square equal by 3.42 times 10 power of negative 3 square divided by 3 times 0.05 power of 5 times 3 times 0.1 power of 5 is equal by 0.019 meter cube per second. V2 equal by Q2. So the work is pi times 0.1 square divided by 4 equal for the answer is 2.42 meter per